Okay, let's do number 36. So you have 25 divided by 4 minus 3i. And our job is to write it as a plus bi. Okay? Now, when you have a denominator, in order to, because eventually we don't want any denominator here, at least in the I in the denominator, what we do, what we talk about in class, you rationalize this thing. And what that means is like this. You multiply by 4 plus 3i and divide by 4 plus 3i. Notice that this is a 1, so it doesn't do anything to that. But the reason we do it is that this denominator becomes 4 squared plus 3 squared. That's what it becomes. Okay? And, I'm sorry, 4 squared minus, no, plus, yeah, plus 3 squared. That's correct. Good. And on the top, you have 25 times 4 plus 3i. Let's do a cleanup here. This is equal to uh, 25 times 4 plus 3i. And this denominator is also 25. So this cancels that, and you have 4 plus 3i. There. And it looks exactly like this. So when you have I in the denominator, you've got to multiply the top and the bottom of that fraction by the what we call the complex conjugate of this number, of complex conjugate of this number, and proceed. So another one, number 38, which looks like this. 2 minus 3i to the power minus 1. Now keep in mind that I don't have a denominator in the usual sense, but the meaning of this, of course, is 1 over 2 minus 3i to the power minus 1 is this. And what we're going to do is we're going to multiply the top and the bottom by the complex conjugate of this, which is 2 plus 3i. 2 plus 3i, that does not make a difference because this whole thing is a 1. And we know that because of what we did in class, this top, the top, of course, is going to be 2 plus 3i because it's 1 times that. And the bottom is going to be 2 squared plus 3 squared. Okay? And this is going to be 2 plus 3i. This denominator is, okay, this is a 4 plus 9 is 13. And since we were asked to write it as a plus bi, we're going to write it like this. 2 over 13 plus 3 over 13 times I. Now this looks exactly like this. A is 2/3, 2/13, and B is 3 over 13. Okay, let's go to the next one. Number 40. 40. And it looks like so. Minus 3 plus 5i divided by 15i. Okay, now we do exactly the same thing. We multiply the top and the bottom by the complex conjugate of the denominator, complex conjugate of this. Now first, let me write this thing for you. 15i, this is the original thing that was given to us right there. And then the complex conjugate of denominator is minus 15i. And of course, the same thing in the top, minus 15i. Now, the beauty of this is that this denominator is going to be 0 squared because you can think about it as 0 plus, right? 0 like that. 0 squared, we don't even have to write it, plus 15 squared. And the top is just patiently write it, minus 3 plus 15i times minus 15i. We have to clean it up though. Okay, so this, first of all, the denominator is 225. We know that, okay? And on the top, you do a foiling. So minus 15i times minus 3 is 45i. And then minus 15i times 5i. Let me write it like that. Minus 15i times 5i. I'm foiling this guy now. Let's clean it up. So it's going to be 45i. And this is going to be minus 75i squared divided by 225. Now, remember, I squared is minus 1. So let's write this thing as 45i minus 1 times minus 75 is plus 75. divided by 225. And we're going to write this thing as 75 over 225 plus 45 over 225 I. Remember, we were supposed to write this thing as A plus BI, and we just did it. There's your A, and there's your B. Next one looks like this. This is number 42. 1 plus 2I times 3 minus I divided by 2 plus I. The first thing we're going to do is to clean up the top so that it's not a multiplication like that. So of the denominator, I'll leave it like this, no problem. So this, you FOIL it, 1 times 3 minus I is going to be 3 minus I. See, I'm taking this and folding into that expression. And then 2I plus 2I times 3 minus I. Let's do it. 3 minus I plus 2I times 3 is 6I. 2I times minus I, see that? This times minus I is going to be minus 2I squared over 2 plus I. Let's do a little bit more cleanup here. So that's going to be 3 plus 5I, correct? And then remember, I squared is minus 1. So times minus 2 is plus 2. So this top is going to be 5 plus 5I. 2 plus I. Look, guys, I do make mistakes when I do some. I might make mistakes when I do some of these algebra, but when you watch it, you pick it up there any mistakes and make sure you don't do that when you're trying to do the problem yourself. No problem. Now, this is not finished yet because we are supposed to write this thing. Remember, in the form of a plus bi, but it has a denominator, so we have to rationalize that denominator. So it's going to be 2 plus I, 5 plus 5I. And on the top, I have 2 minus I, and over here, I have 2 minus I. You multiply the top and the bottom by the same thing so that you don't disturb the value of this guy, okay? So this is going to be, the denominator is 2 squared plus 1 squared. And on the top, we have 5 plus 5I times 2 minus I, okay? Now, uh, let me uh, let me FOIL it, okay? So it's going to be 5 times 2 is 10. 5 times minus I is minus 5I. 5I times 2 is going to be plus 10I. And then 5I times minus I is going to be 5 minus 5I squared, and I squared is minus 1. So this is a plus 5 divided by 5, okay? Let me wrap it up here. This is equal to, on the top, I have 15, because 10 plus 5 is 15, and then plus 5I divided by 5. And if you wrote this as 15 over 5 plus 5 over 5I, you have it all the way down to the 3 plus I. Now, even if you wrote it like this, it's going to be perfectly acceptable to me, but believe me, the answer in the book is not going to be that guy. The answer in the book is going to be after you clean it up. Okay, so let's go to the second last box. It says eval, this is number 44, for example. It says, here's the situation, minus 9 plus 4. Write it as a plus bi. Okay? Evaluate the radical expression and express it in that form. Okay, so no problem. So this is going to be root of, let me write it like that. Let me write it like that for you. A minus 3 over 2 squared, right? Isn't that the same thing? It is the same thing. So it's going to be root of 3 over 2 squared times root of minus 1. And this is 3 over 2 times I. So we did write it like that. Of course, the real part of it is 0. And the imaginary part of it is 3 over 2. But just compare. This looks like that, where A is A is 0 and B is 3 over 2. Okay. Next one, number 46. Same kind of a problem. 1 minus square root of minus 1 over 1 plus square root of minus 1. So this is going to be 1 minus I over 1 plus I. And we want to, because we want to write it like that, so we're going to multiply the top and the bottom by the complex conjugate of what's in the denominator. What does that mean? 1 minus I, 1 minus I. Okay? So this is going to be 1 minus I times 1 minus I. Okay, that's good. Divided, but this denominator is 1 squared plus 1 squared. So this is going to be, let me write it like that, 1 minus I to the, well, times 1 minus I. Okay, I can write it as power 2, but I'll write it like this. And now we have to do it right here. I'll put the 1/2 there, and I FOIL this. So it's going to be 1 times 1 minus I, and then minus I, that guy, FOILed with the thing on the right side of it, 1 minus I, and then clean up 1/2. So this is a 1, right? Yeah, so that's going to be 1 minus I. Minus I times 1 is minus I. Minus I times minus I is I squared, which is minus 1. Okay? I'm going to double check this thing, make sure it's okay. So these ones cancel. This cancels that. 1 is plus, the other minus, and this is going to be 1/2 of minus 2I, and it's equal to minus I. Now, let me just double check, make sure there's no mistake here. This is what was given to us right there. Very good. This is 1 minus I over 1 plus I. Excellent. Multiply the top and the bottom by the complex conjugate of the denominator. Fine. The top is going to stay the way it is. The bottom is going to be 1 squared plus 1 squared. Okay, good. So that's a 2. And then we FOIL this thing. We're going to FOIL this into that. So it's going to be 1/2 of 1 times 1 minus I, fine. And then there's a minus I times 1 minus I, very good. So this is going to be 1 times this, 1 times 1, minus I, minus I. Yeah, that's a mistake. There's a mistake here. Oh no, it's okay. So minus I times minus I becomes I squared, and I squared is minus 1, which I wrote. These cancel, and I get this. So I'm pretty sure it's okay. If not, let me know. Okay, let's do the other one, number 46, which goes like this. I think it says root of 1/3 times root of minus 27. Now, what we can do here is we can see that under the same radical, we can write everything under the same radical. 1/3 times minus 27, and this is root of minus 9, right? And this is 3 root of minus 1, and this is 3i. That's it. 52. 52 looks like this. Minus 7, minus 49, divided by 28. There are different ways of doing these things. That's entirely up to you. I'm not suggesting that you do it this way. It's up to you. So think about it like that. Uh, you uh, this is one way of doing it. Okay, minus 7. This is minus 7 squared, correct? And this is root of 4 times 7. Okay, so this thing is going to be minus root 7I. That's this guy. This fellow, let me write it like this. Different color perhaps. This fellow, think about it as root of minus 1 times root of 7 squared, right? So it's going to be times 7I, right? Yeah. All right, and down below here is going to be 2 root 7. That guy is 2 root 7. There's some cancellation. This cancels that. And we have, let me write it like that, minus 7I squared, right? So there's a minus here, which I wrote it there. I times I is I squared, right? And 7 is going to stay. And there's going to be a 2 here. And remember, I squared is minus 1. So this is 7. This is minus 1, right? So this is going to be 7 over 2. That's it. Let's do number 54. It says write all solutions of this equation and express them in the form a plus bi. Okay, 9x squared plus 4 equal to 0. Okay. Now, this is a simple enough problem that you can do it without quadratic formula. You can if you want to go that route, but you don't have to. So we got 9x squared equal to minus 4, x squared equal to minus 4 over 9, x equal to plus or minus root of minus 4 over 9. However, this is the same as plus or minus 2/3 square root of minus 1, right? So it's going to be plus or minus 2/3 of I. I did not have to use the formula quadratic because it's simple enough. I just wrote x squared in terms of everything else and then took the square root. Okay. Let me do the next one. Okay. Next one is 56. And x squared plus 2x plus 2 equal to 0. Here, it is wise to use the formula for quadratic. And let me see, this in the book. So your a is 1, your b is 2, and your c is also 2. So x equal to minus b plus or minus root of b squared minus 4ac over 2a. So it's going to be minus 2 plus or minus square root of 2 squared minus 4. A is 1, c is 2, divided by 2, 1. So this is equal to minus 2 plus or minus square root. And this is going to be minus 4 minus 8, so it's going to be minus 4 over 2. This is going to be minus 2 plus or minus 2 square root of minus 1 over 2, which means 2 plus or minus 2i over 2. And finally, if you wrote it as 2 over 2 plus or minus 2 over 2i, you have your answer, 1 plus or minus I. There's two solutions. One of them is x equal to two complex solution, 1 plus I. The other one is x equal to 1 minus I. That's what this plus or minus means. There's two solutions. Okay, the last problem. Let me insert the slide here. Okay, the last problem is number 58. And it goes like this. X squared minus 6x plus 10 equal to 0. So A is 1, B is minus 6, and C is 10. Okay, so X is equal to minus B minus minus 6. Minus B means this. Minus, and B is minus 6, okay? Plus or minus square root of minus 6 squared plus minus 4, your A is 1, and your C is 10, divided by 2 times 1. So this is going to be 6 plus or minus square root of, this is 36 minus 40 divided by 2. This is 6 plus or minus square root of minus 4 over 2. This is 6 plus or minus 2 square root of minus 1, right? Over 2. 6 plus or minus 2i over 2. And this means 3 plus or minus I. 6 over 2 and 2 over 2, right? So one complex solution is 3 plus I. The other complex solution is 3 minus I. And that completes the homework for today. The quiz coming up on Wednesday is going to be dealing with problems of this type. Please practice.